Let's look at integrals for sines and cosines. Let's start with y equals sine omega t, where t is time. The integral of sine omega t with respect to time is negative 1 over omega cosine omega t. And we can check that because the derivative of cosine is negative sine. And then we'd also have to do the chain rule and take the derivative of omega t, which would be omega, so that we get right back to sine omega t, our original function. For y equals cosine omega t, the integral is positive 1 over omega sine omega t. Let's draw a sine curve. Here's my time axis, and here's my y-axis. And that's one cycle of a sine curve. In this location is time equals capital T, the period. And we started out at t equals 0. And for a sine curve, it goes between positive 1 and negative 1 on the y-axis. If we look at the area over this whole cycle, we have positive values here and then negative values here. That integral over the whole period is 0. The integral of sine omega t from 0 to period capital T is negative 1 over omega cosine omega t evaluated at 0 and t. So this is our definite integral. We need to draw in our cosine function. So at time capital T, the cosine is 1, and at time 0, the cosine is 1. So we have cosine omega capital T minus cosine of 0. And from looking at the graph, we know this is 1 and that's 1. So it's 1 minus 1, which is 0. Let's try an integral from t equals 0 to 1/2 the period, capital T divided by 2. Now we're only looking at the area under this part of the sine curve. My limits now are 0 and capital T divided by 2. Nothing about indefinite integral changes. It's just where we evaluate it. So of cosine omega capital T minus the cosine of omega times 0, cosine of 0. At capital T divided by 2, the cosine function is negative 1. And at 0, it's positive 1. So we can write -1 minus +1. And that is 2 over omega. And remember, omega is defined as 2 pi divided by the period. We could also write this as the period, capital T, divided by pi. I also want to point out that we can add in an amplitude, and I'll just go through and do that everywhere. So it's y equals capital A for the amplitude sine omega t, and this one it's capital A cosine omega t. We can put the amplitude inside the integral or outside the integral. You'll get the same result. I'll put it outside. And it's negative a over omega and positive a over omega instead of the 1 over omegas. And it's the same thing here. I hope that helps your math.